Okay, today we're going to discuss derivatives of carboxylic acids. This is a chapter as we started yesterday or in the last class, that is the carboxylic acid and its compounds. And today we are going to discuss the derivative of carboxylic acid. Carboxylic acid is organic compounds which contain this much functional group, and the compounds in which if you replace this OH with any other atom or group which does not contain carbon or directly attached with the carbon is categorized as the derivative. For example, in the first case, if I replace this with Cl, right? So it becomes RCOCl. That is another separate functional group, but we just categorize it in the category of derivative that derived from carboxylic acid. And they are known as acyl chlorides. In a while, we are going to discuss them in a detail. Number 2, RCO. And instead of OH, if I place OR, O mean oxygen, R mean carbon chain. We know these compounds very well since O level. What are these compounds? Esters. They are again categorized as one of the derivative of carboxylic acid. Number 3, RCO. If I put NH2 here, this is actually NH3, na? If one of the hydrogen of NH3 is taken away and the rest of the part is attached with CO instead of OH, this is called RCO NH2. Yes. And this group of compound, this functional group is known as amide. And the last one is RCO. And if I, in this case, I'm going to replace this hydrogen with another carbon chain like this. Okay? So this is RCONHR. Okay? So this is actually the same functional group amide, but the only difference is that the amide's nitrogen has been substituted with another carbon chain. So therefore you call it nitrogen substituted. Yes, nitrogen substituted amide. Okay, is it clear? So these are the 4 group of organic compounds, right? Acyl chlorides, esters, amides, and unsubstituted amides. They are categorized as the derivatives of carboxylic acids, right? The first one, let's start one by one. The first one is acyl chlorides. We are going through the details of these compounds. Acyl chlorides, as you can see, the general formula is CnH2n plus 1 COCl. Functional group, as you can see, CO and then Cl or COCl. Here is the functional group. The first member, it can't have one carbon. The first member is like this. How many carbons? 2. And as far as their name is concerned, the alkanes E replaced by OYl chloride. Functional group. So it becomes alkanoyl chloride. Okay. So at this moment, if this is alkanoyl chloride, mean 2 carbon is ethane. And this is what? Ethanoyl chloride. This is what? Ethanoyl chloride. Okay. Yeah, ethanoyl. This is when you have an acyl chloride. This is ethanoyl chloride. Okay. Similarly, look, if there are 3 carbons, propanoyl chloride. Propanoyl chloride. Propane means 3 carbon. So OYl chloride. And why I'm not mentioning the position? Because it always coming at carbon number 1. So when the functional group is present at carbon number 1, you don't need to mention the position. Okay. Similarly, 1, 2, 3, 4. Sorry. What is this? It's not just butanyl chloride. There is a branch as well. 2-methyl butanoyl chloride. At times they give you the skeletal one. You don't write C. Here it is. What is the name? 1, 2, 3, 4. 2, 3 dimethyl. Noyl chloride. So one more thing. There are 2 methyl groups attached. Look, here is methyl, here is methyl. 2 branches. Now one more thing before I move on, which I want to tell you. Everyone pay attention. This is C6H6. What is the name of C6H6? It is what? Benzene. This is benzene. If one hydrogen is lost, it becomes what? C6H5. You don't call it benzyl, you call it phenyl. Not benzyl, call it phenyl. But if you have once, well, naam hai na, rule hai ye. And once you have, instead of that hydrogen, you have CO, then you call it benz. What do you call it? Benz. Okay. So C6H5 CO C6H5CO is benz. C6H5 is phenyl. And C6H6 is benzene. Yeah. Yeah. वो C7 हो गया ना. C6H5CO is benz. Okay. But phenyl is C6H5. Okay. Now coming back to this. What about the name of this? This one. What about this? Benzoyl chloride. Benzoyl chloride. Okay. Okay, now preparations. That's all about the naming. Preparation of acyl chlorides. Acyl chlorides prepared from their kind of parent compounds known as carboxylic acids. Okay, look at this. When you react it, this reaction we have already done in AS, you remember? If I reacted with PCl5, you remember? This Cl was going to take the place of this OH. This has been done in AS with alcohols. Okay, now with carboxylic acids. So it becomes CH3CO, and then what it becomes? Cl. Plus the byproduct is POCl3 plus steamy fumes of HCl. Okay, these reactions are vigorous. So here are the steamy fumes of HCl. So you see, it was a test. Sorry? No, this is substitution. Ethanoic acid to ethanoyl chloride. You can also use PCl3 if you want. Okay. For example, if I take benzoic acid, here it is, plus PCl5 gives us benzoyl chloride plus POCl3 plus HCl. Okay, so here they are prepared. Now reactions of acyl chloride. Reactions of acyl chlorides. Okay, now if I tell you, listen, in all the reactions of acyl chloride, what happens? They're very similar. Please pay attention. They are very similar to the reactions of haloalkanes, which we did in AS. If you remember, in haloalkanes, the halogen was always substituted with an incoming nucleophile. The same thing happens here, that a nucleophile comes in. I'm writing an U, and it's going to replace what? This Cl. So what is the product? RCO and then a nucleophile. And the Cl is gone out as a nucleophile. So it's almost the same reaction, right? As they were happening in haloalkane. But these reactions, acyl chlorides, if I tell you, are reactive organic compounds. Why reactive organic compounds? Because usually, you know, organic compounds are not very reactive. Why are they reacted? Look at this. There, in this substitution, which bond breaks? CCl bond. Na? Nucleophile, yeah. Or acyl chlorides are reactive organic compounds. Why are they reactive? Look at this. Please pay attention. In this case, this CO, oxygen has a very high electronegativity. So this CO is actually pulls the electron density towards itself. making this Cl bond what? Weaker. So that's why the acyl chloride, as you can see, this Cl bond breaks now when nucleophile comes and takes the place of Cl. So CCl bond breaks. So in acyl chlorides, CO is a very strong electronegativity of oxygen, acts as an electron withdrawing group, pulls the electron density towards itself, making CCl bond weaker. Hence, all the reactions of acyl chlorides as they undergo the substitution of Cl. So all the reactions of acyl chlorides are very fast, are not slow like organic compounds which need a heat or anything. They're most of the reactions or all of the reactions take place at room temperature. Yes, the high electronegativity mean pulls the electron towards itself. So CCl bond is weaker. So please write down they are reactive organic compounds. Why? Because C double bond O acts as electron withdrawing group, pulls electron density towards itself, making CCl bond weaker. Hence more reactive. Electron withdrawing group. I'll explain it in the next part when we'll be doing the hydrolysis and their comparison. So that's why I'm going to just give you the information on need to know basis at this moment. But I just wanted to clarify that most of the reaction won't need any temperature or anything, right? The reason is this. Okay, now let's see their reactions. Okay, I'm going to write their reactions in one go. I would like you to stop and just listen to me before you copy this. Look at this. This is an acyl chloride known as what? Ethanoyl chloride. What I told you a while ago, whenever they react with anyone, their nucleophile comes and takes the place of what? Cl. So one by one, let's see. First, let's see their reaction with water. Their reaction with water. Water is what? H2O. In organic reaction, I used to write them HOH, the water ka formula. Okay. Now, what is the water's nucleophile that go and take the place of? Yes. How you identify a nucleophile? If there is a metal present in that compound, just remove that metal. What is left behind is the nucleophile. If there is no metal, just remove the hydrogen from that. Whatever left behind is the nucleophile. So water's hydrogen is removed and water's nucleophile is what? OH. This OH is going to take the place of what? This Cl. So what is the product then? CH3, C double bond O, and then what? Yes, the OH is going to take. Plus this H and Cl, they're going to combine to make HCl. So you see, ethanoyl chlorides reaction with water, which is also known as hydrolysis, taking place at room temperature, gives what? Its parent compound. What is this? Ethanoic acid. So it gives back ethanoic acid. And it's very vigorous reaction. It's a very vigorous reaction. Okay? Steamy fumes of HCl. Okay? Let me finish this, then I'll let you see that. Okay? Look at the second reaction. That was the first one. The second reaction, when I mix them with ethanol, which is C2H5OH, or phenol, which is C6H5OH. Okay? Once you react them with ethanol or phenol. Okay? What is the product? CH3, C double bond O. Now, what is gone? For example, first let me write the product with ethanol. What will be the ethanol's nucleophile? Just remove its hydrogen. This hydrogen. This hydrogen is going to go with HCl to make what? With Cl to make what? HCl. So this part is going to go and take the place of Cl. So what is the product? O C2H5. This is what? Ester plus HCl. And what about phenol? What about phenol? CH3, C, double bond O. And what next? This H is gone again. So next, not benzene ring. This O is going to take the place of Cl. This O. And then there is a benzene ring. Right? This is again ester. This is phenyl ester. That was ethyl ester. Okay? So in both these cases, with phenol and alcohol, they turn into ester. And ester is one of the other derivative of carboxylic acid. So in the first reaction, the parent compound was formed. In the second two reactions, one of the other derivative is formed from the reaction of acyl chloride. Okay? Now let's see how the acyl chlorides react with ammonia. Ammonia is what? NH3. Okay, and one more thing I tell you, you see in both these reactions, the HCl is formed, and we know the esters undergo hydrolysis with HCl. We learned it in AS. So therefore, we have to use NaOH aqueous in all these reactions to neutralize the HCl formed. Okay. Next, what about this? What is the nucleophile of NH3? NH2. That comes and take the place of Cl. So it becomes CH3CO NH2. Right? If this was the ester, what is this compound? Amide, which is another derivative. Again, this derivative can also undergo the hydrolysis with HCl, so we have to add what? NaOH to stop that. One more thing, let's react them with amines. This was with ammonia. No, that doesn't need, okay? Because the acid is formed. Acid doesn't go hydrolysis with HCl. The next one with amines. Right? For example, if I react it with CH3NH2, or if I react it with phenylamine, this one, C6H5NH2. What is the product formed? What is the amines nucleophile? CH3NH. That is going to come and take the place of Cl, and then NHCH3. Okay? Plus HCl. Again, what is this? Another derivative known as what? N-substituted amide. So kind of amide, okay? And again, if we react it with phenylamine, what will be the product? Yes, the benzene ring. This is again N-substituted amide plus HCl. Yes, because they can also undergo hydrolysis. So in order to neutralize the HCl, we need NaOH actors. So you see in acyl chlorides reactions, in one of the reactions, the parent compound is formed, the carboxylic acid known as hydrolysis. In all of other reactions, the fellow derivatives, amide, ester, and substituted amide is formed, right? So all these reactions. Now we have to look at the mechanism of this, right? So mechanism, how this reaction takes place. I hope you have done the copying all this. I'm going to give you 1.5 minutes. Okay, let's go for the mechanisms now. The first reaction was hydrolysis. I'm going to rewrite the reaction. CH3COCl plus HOH, room temperature. The reaction is CH3COOH plus HCl. Ethanol chloride turns into what? Ethanoic acid. I always tell you one thing. A reaction just tells you what happened. When you look at the mechanism, it tells you how it happened. In mechanism, you have to see all the details, how the bonds broken and how the bonds formed, where the electrons are gone, where you have to show a complete movement of electrons, formation of new bonds, breakage of the previous bond, right? Which have to show. So in short terms, as I said, that reaction tells you what happened, that acyl chloride, ethanol chloride turned into ethanoic acid, but how this all happened, this is the mechanism is going to tell you. This mechanism is 2 steps. You may be thinking that it seems to be the substitution, but it is not. Okay, not the one which we did in AS, the nucleophilic substitution, right? It's a kind of substitution, but how? Look, if I look at this, you know, due to the electronegativity distance, this is partial negative, this is partial positive, and this is again what? Partial negative. Now, when you reacted with water, please pay attention. Water can act as a nucleophile because it has a lone pair of electron with oxygen. So water is going to use this lone pair of electron with oxygen to form a dative covalent bond with carbon. You know, in organic, most of the bonds they are going to be formed, they're always dative. This bond with the sharing, but the shared pair electron is given by one atom. So here, oxygen is trying to make a bond with carbon, but carbon cannot expand its octet and cannot make this bond until it has to break one of its covalent bond, right? Heterolytically, and give these 2 electrons to the oxygen and accept the electrons from the oxygen of water. And it turns into this CH3C single bond O, negative charge. Here is the electron pair that is gone. Here is the Cl, and now the OH is attached with this. And this is kind of addition of nucleophile, right? It is the addition of nucleophile. In the first step. Now, in the second step, and this is the intermediate form. In the second step, the simplest term, if I tell you, the elimination is going to take place. What is this elimination? Look, this Cl and this H, they are going to eliminate. You're not supposed to make this dotted line. You just have to tell me how they are going to eliminate. Look, this bond is going to break by heterolytic fission, and both these electrons are taken by Cl, being more electronegative. And this bond also breaks by hydrolytic fission, and both these electrons are taken by oxygen, being more electronegative. And in the meanwhile, yes, these curly arrows, always there is a language. These curly arrows is a language which tells you where the electrons are going. Either you write it in words. So in mechanism, instead of writing the whole story in words, we are just showing it with the arrows. If you miss one of the arrows, so it means you are missing the major part of the story. So they're not going to give you any mark. And similarly, this lone pair comes back. And carbon's double bond will be restored. Now, as a result, here it is. CH3, C, double bond O. Now the Cl is gone. Here is O. Here is H plus HCl is formed. You see, So this thing here is what? CH3COOH. So in the second step, precisely elimination happened. What happened? Elimination. Okay. So the first step is nucleophilic addition, and the second step is elimination of HCl. So therefore, this mechanism is named as mechanism known as nucleophilic addition elimination. Addition elimination. Okay. So it's a two-step mechanism, first and second. On all these reactions above mentioned, follow the same mechanism known as nucleophilic addition. So 1, 2, 3, 4, 5 arrows along with this intermediate, they all carry the marks. Now I'm going to give you one more, right? If you have any question, please go ahead. Otherwise, this is the how the mechanism happens. So all these four reactions which we mentioned on the top, they follow the same mechanism. Okay. Now I'm going to give you one of them and you have to do it. I'll follow. Look, this is first you have to write the product, benzoyl chloride, reacting it with phenol. First write the product and then mechanism. What's the name of the reaction? This is no name, reaction with phenol. And then benzoyl chloride with CH3NH2 and the mechanism. And then benzoyl chloride plus NH3 and the mechanism. Here you go. Can go to the presence after payment. I'm going to do the phenol 1G. Parent. What happens? The O joins with the C. So it's HCl plus CO, and then, yes, it's a ketone. Yeah. It's going to be ester. Like this. Okay, now mechanism. First, you have to show the charges. And in the first step, yes, the oxygen's lone pair. Here, here. And then what is the intermediate formed? Single bond. Here the lone pair. Now this oxygen is connected with C6H5 on one side and H on the other side. And this is what Cl. Okay. Now what happens for the elimination? This bond broken, this bond, then this one. What is formed? What is this? Double bond O. And then what is this? O. And then this plus HCl. And the mechanism is known as phenyl ester. Phenyl benzoate. Phenyl benzoate. Got it? Okay, we'll continue this. That's all from my side today. Thank you very much. We'll continue this. So once again, CH3